Hi guys, welcome to our last day 13 video. We're going to talk a little bit about the Pythagorean Theorem. We are on page 190 of the notes packet in your course packet. Notice the top of this is supposed to be a proof of the Pythagorean Theorem, but we are actually going to be doing that as a possible activity tomorrow. So I'm going to not do that with you guys. For now, we're going to assume that the Pythagorean Theorem is true, and we'll look at proving it tomorrow. So Pythagorean Theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. And what that is saying is a squared plus b squared is c squared. And that's representing these side lengths over here, and it only works for a right triangle, and the two smaller sides squared equals the larger one, which is called the hypotenuse, and that's the one across from the right angle. Okay, so let's look at some examples. Here's a couple of quick examples. This one's real easy. On a map, Salem is 28 miles due south of Springfield, so I'm going to put Spring. And then 28 miles south, we get Salem. And it says Salem is 28 miles due south of Springfield, and Salem is 45 miles west of Richmond. So I'm going to make this one longer. Okay, and so notice we make a right triangle. And then they ask us, how many miles is Richmond from Springfield? So we're looking for the hypotenuse. So using a squared plus b squared equals c squared. My a squared is 28. My b squared is 45. We're going to solve on the calculator once it loads. So 28 squared plus, I'm putting that in parentheses, 45 squared. And then we get 2809 is equal to c squared. Okay, and then we need to do second square root, second answer, which is 53. So c is the square root of 2809, which is 53 miles. So that's one straightforward example, is using distance. Okay, I'm going to read through the directions just to point out a couple vocabulary terms, and then I want you guys to try and do number 2 on your own. So it says chord AB, and that's from A to B, is 18 centimeters long, and it's tangent to two circles. Or tangent to the smaller of two concentric circles. All that means is that the little circle on the inside, AB, touches it at one point. So that's what it means to be tangent, is that you touch at one point rather than 2 points or no points. So in solving this, I do want to start you guys off with one tip. The one tip is that I would call the little radius R, and I would call, excuse me, this side is representing your big radius. I would call that big R for now. So using those variables and what you know in the context, remember you're looking for a Pythagorean theorem, you are allowed to assume that that is a right triangle there. So go ahead and try it on your own, pause the video, unpause to check. So I assume that you probably set it up, you've got your right triangle as I do here, and you plugged it into Pythagorean theorem. And you probably stopped at this, 81 plus r squared is big R squared. You can also rearrange it and say 81 is equal to big R squared minus little r squared. But then you probably got stuck. The key is that we are looking for the area between the two circles. So that's pi r squared big circle minus pi r squared little circle. Because remember, we're using our area circle formula, pi r squared, and we're going to be subtracting them. So if I take out a greatest common factor of pi, I can rewrite this in this fashion, which is really nice because big R squared minus little r squared is what I know already. So then from here, I'm going to substitute in that is the same thing as 81. So your answer is 81 pi centimeters squared. Okay. On the next page, we're going to be exploring something called special right triangles really briefly. I'm going to introduce you to them. There's a couple of application problems here. Okay. So special right triangles. There are two special right triangles that occur really frequently. They do occur in competition problems as well as in standardized testing. They'll show up on the ACT, the SAT. They show up in the GRE, which is something that you need to take to get into grad school. So they come up in a lot of contexts, so it's really useful to know. So what is the diagonal measure of a square whose sides are 3? So here's a square, 3, 3. We're looking for the diagonal. Okay, so we do have a right triangle, so you would do 3 squared plus 3 squared equals x squared, if I call that x. So 9 plus 9 equals x squared, 18 equals x squared. So you could say x is the square root of 18. Well, that's the same thing as square root of 9 times square root of 2, using our simplifying radicals ideas. And then you could say x is 3 square root of 2. And then if you do the same thing, and you have a side length of x and x, what you'll find is that this distance is equal to the square root of 2x squared, which will simplify to x times the square root of 2. So it is a simplified version. It's like a general version of this, right? Notice you always have the side length times square root of 2. So for your triangle like this, we call it a 45, 45, 90. That's because the triangle itself that we're looking at has a 90-degree angle, and this is 45 degrees, as is the bottom angle, because I'm slicing a square's corner in half. So that's what we figured out right here, is that for a special right 45, 45, 90 triangle, it's got a root 2. Generally, you actually do see x's, so I'm just going to put x square root of 2. Okay, and that's going to be something that you'll use to solve for problems. You can put an example over here if you want. So here's a 45, 45, 90 triangle. Notice I've added the angles to show that it is. You could have 5, 5, and 5 root 2. Okay. For 30, 60, 90, if I have an equilateral triangle whose sides are 4, and if I want to know what the altitude is a really fancy word for the height. Kind of like the altitude of a mountain is the height of a mountain. So the sides are 4, so that means this is 4. This one would be 2, because I'm cutting the other 4 in half. And I'm looking for the altitude, which makes the right angle. So I'm going to redraw this nice triangle over here. I've got 2, 4. To get this other side, I'm going to call it x. And now, Pythagorean theorem, remember, you want the two smaller sides squared. So 2 squared plus x squared equals 4 squared. So some people accidentally put the two numbers that they know next to each other always, but notice we are looking for one of the smaller legs. So 4 plus x squared equals 16, which means x squared is equal to 12, and x is the square root of 12, which will simplify to square root of 4 times square root of 3. So it's going to be 2 square root of 3 is our final answer. So I'll put that over here, 2 square root of 3. And then if you generalize it, the general rule, and I'm just going to make these x's again. If you have little base, right, which we could call that, like I call it the base or the little leg is what you can call it. The shorter leg, the little leg. And then you have 2 times x, if I'm switching to x, that's your hypotenuse. And then x times the square root of 3, that is your longer leg. Sometimes I call that the height. But the hard thing is if you take that triangle and you like put it sideways, that it looks like the base. So I think calling it the little leg and the longer leg is a little bit more universal. And I do want to add in, I did not have these angle measures here before, the 30 degrees, the 60 degrees, the 90 degrees. So can you please add those in? Remember the 45 degrees were because we were cutting the right angle in half. The 60 degrees is coming from its equilateral triangle, right? And one of those 60 degrees was sliced in half. So that's going to be it for tonight. These application questions we can add to the practice tomorrow. You guys can try them if you would like to. And then the distance formula, I'm not really going to go over. I'm trying to cut some of the stuff down so you guys don't have a lot to watch video-wise at home. But we can talk about this tomorrow if you guys want to at the beginning of class. It's really just an application of Pythagorean Theorem, so I don't think that there's a need to memorize a new formula. So we can talk about these guys when we talk tomorrow. Have a great night.